Good afternoon. Good afternoon and welcome to this webinar on data science. Can I get some response in chat box? Am I audible? Can you see my screen? Good afternoon, dear participants. Good afternoon, good afternoon. Good afternoon and once again welcome to this session on data science. So this webinar or this workshop I'll be discussing about the overview about data science, the tools of data science and the process. Okay, everything I'll try to grasp in this particular session. You can't see about in depth of all these concepts in just 1 hour. But anyway, we'll try to see the overview, and finally I have a project where I'll be showing you a demo of practical implementation of data science and how it can be really helpful for improving business or finding meaningful insights from the data, right? So before starting this session, good afternoon, thanks for the response, and please keep this session more interactive. I'll be asking some questions in between, and whether it's right or wrong, I want you guys to post down some answers which you have in your mind. We can discuss about it. Fine. So what is data science? What do you have in your mind about data science? Do you have any idea about it? You already working on it, or you guys, or it's a new field? The data science, what does that mean? Any idea? I'll be giving you a few minutes of time to post down the answers in chat box. You can use chat box to post these answers. Good afternoon. Good afternoon. Yes, what is data science? Any definition or any idea which you have about data science? So talking about data science is the art of turning raw data into insights. Okay, so with vast amount of data nowadays available, data science helps make sense of it, all the data, by using statistical and computational methods to extract meaningful insights. Okay, so it performs some math statistics and some computational methods. So from your raw data, you are trying to get some meaningful insights. With the help of that, you are trying to improve your like it could be a business or it could be a case study or whatever you are performing on. Yeah, Jitesh, doing some operations on data, yes, that's the base. Data science is the study of data to extract meaningful insights for business. Yeah, correct. That could also, you can define that. So data is everything. Nowadays, everything belongs to data, right? Whether you fill a form, they collect your data. The mobile phone you are using, the companies, they are collecting your data. The apps you are using, the Instagram or any social media, they'll note down all your data. Okay, companies like, for example, in Instagram, if you go inside of it, you can get insights of your own analysis. Do you guys know about it? So if you go inside of it, they'll tell you the data of in which day how many hours you have spent on. Okay, in the Instagram, what's the average time you spend there, and they'll give you some topics of what is the like things you like. Okay, those things and all they are collecting and storing and then doing something in that data, so that okay, they can find some way that, for example, they can segregate a group of guys and they can like provide, the algorithm can suggest some like feeds which the person likes, so that they will spend more time on their app, right? So this is one of the practical implementations of data science. And yeah, we know that somehow you can collect the data. It's not a big deal to collect data. So when you have this bunch of data, what you are going to do it, how you are going to achieve this feat. And to do that, there are a lot of steps and process and tools involved here. For example, before going into that, I'll tell you, before talking in depth about how this data science works, I'll tell you what is the future of decision making and data science application. So in today's data driven world, business, organizations of all kinds rely on data to make informed decisions. And data science play a critical role in this process by providing tools and methods needed to extract valuable insight from the data. And Just to tell you guys, science is now for everyone. It's not like it belongs to only the traditional IT field. So while data science has traditionally been associated with technical fields like computer science and statistics, it's becoming increasingly important across all industries and disciplines. And anyone can benefit from learning data science skills, whether they are working in a healthcare department or finance, marketing, or from any other field. So let us see some applications of data science. And in healthcare and all, we have real-time applications of disease diagnosis and prediction. So some algorithms or models can be trained on large amount of patient data to identify patterns and predict likelihood of certain diseases or condition. For example, predictive models can be used to identify patients at a high risk of developing heart disease, diabetes, or any other conditions. So they can get the details of the patient and tell them that whether they are susceptible to such particular disease, and if they are at high risk, then what should they do. So this is one of the predictive thing, right? Talking about finance, data science can be used to predict various financial outcomes like stock prices, interest rates, economic indicators and all, and this can help financial institutions make more informed decisions about investment and other financial activities. And guys, like stock and all, they follow the previous trend and patterns. Something which happened in the past will repeat once again, and that's what data science is. It analyzes the data and give you a result. And if you can find, for example, with the help of this predictive analysis, if you predict that if you predict that the future the particular sales is going to go down, so you can withdraw some stocks from it, right? So these kind of predictive analytics can be done with the help of data science. And also in pharmaceutical industry, like drug discovery and development, and I don't know how many of you guys know about this field. Anyway, the data science techniques can be used to analyze large data sets and identify new drug targets or potential therapies. To develop a particular drug, we need to perform a lot of synthesis procedures and all, and their efficacy should be tested, right, in pharmaceutical field in the research and development. So in this particular process, they will be having their past data set about a lot of combinations of synthesis procedures. So with that, they can develop some new pathways or proceed with that. And data science models can also be used to predict the efficacy and the safety of drugs before they are tested in clinical trials. So if you have the data of your past medicines or your past drugs, instead of directly going into clinical trials with some animals, you can first try to predict somehow, like with the help of data science models, how much it could be efficient, and then you can go with clinical trials, right? And in marketing and all, customer segmentation and targeting, as I told you, right, in Instagram or YouTube, so whatever social media you use, they collect your data and they'll try to fine tune your app for your own purpose, so that you will be spending more time on it. So it will improve their marketing and their sales, right? And in agriculture and all, crop yield prediction based on the weather patterns, soil condition, irrigation practices, this can help farmers to plan better their operations and make more informed decisions about crop selection and planting schedules. Is it clear about the applications now? Can we start with the tools of data science? So now I can go in depth about what we need to do to perform something in data science. What is the procedure? What's the tools required? Tell me guys in chat box. Is it clear about the introduction and the applications of data science? Can we start with the tools for data science? Yes, can I get some response in chat box? Fine. So we'll move into the tools for data science. So talking about the tools for data science, these are some of the common tools for data science which is required. For example, starting with Python programming. So you have options of doing with R programming or Python programming. Most commonly Python is used, and you can perform, when you collect your data, you have to perform mandatorily a data visualization. So in the project I'm going to show you today, I'll be explaining you about what's the importance of data visualization. And machine learning is also an important tool, because with the help of machine learning only we will be predicting the outcomes. And if you have your data in the format of human text, we can have it with the help of natural language processing. And deep learning is a part of machine learning, advanced version. I'll explain more about it. And little bit in between, mostly all these things depends on mathematics and statistics. So these are all the tools. So I hope Python programming is clear for you. It's a programming language. With the base of that, we'll be building a lot of libraries and working on it for machine learning and NLP, deep learning and all. So for data visualization, you can either use Python libraries, or you have some business intelligence tools, like you have Power BI, Tableau, right? And then if you go with AWS or Azure, they have their own business intelligence tools, so you can integrate in that and then work on it. And talking about machine learning, NLP, deep learning, I'll explain in the further slides deeply. So starting with this machine learning, so what does this machine learning means? We now know that machine learning is a tool which is required for data science, right? So talking about machine learning, it is the creation of algorithm and models which are capable of making informed choices or decisions by processing data and learning from it. So if you give your data, this machine learning has something known as algorithms and models, or models, both are same, a term to define both. Okay, so if you give your data, it will learn from it. Okay, so if you check about it, this is what the process it. You have a data, okay, and you can't directly give it to your algorithm. The reason behind it is this data which you collected from open source, or you collected from your own forms, or whatever it may be. These data may or may not be correct, so you have to mandatorily go some analysis, understand the data, and then if it requires, you need to do some pre-processing. What all the pre-processing methods, I'll tell you later. So if anything unnecessary things and all, we'll be removing from the data so that the noise can be reduced in the data. And once it is done, I can give it to my machine learning algorithm. So what is this machine learning algorithm is? He is nothing but, okay, it is a bunch of statistical tool. Okay, it performs statistics and give you a result. And furthermore, deep about machine learning algorithms we'll see later. And about deep learning, it is actually a specialized field within machine learning. It's like a part of machine learning, where instead of in machine learning we used that algorithms, right? It's a predefined one. You have some limitations. You can just change some part of the hyperparameters only. But when you go for deep learning, you can build your own artificial neural networks. So these are some advanced version of algorithms where you can define your own neural network. These neural network concept and all is created just to mimic the human brain activity, like the neurons in our brain, and they do a lot of complex process. So here in deep learning, we have the data, we'll analyze and process and give it to neural network. That's the idea behind this deep learning. Is clear? So with the help of these, data science can be done, and also with the help of NLP and image processing, it can also be helpful to achieve artificial intelligence too. And I hope this introduction for the tools like machine learning and deep learning is clear. We'll still see about natural language processing and see the steps involved in machine learning, so that we can actually do a data science project. Starting with that, NLP is a combination of AI, CS and then human language. Okay, so this data, see here guys, it could be mostly in machine learning, this data will be in tabular format. It could be a structured data. Okay, in deep learning you can either have your structured data or unstructured data like images, text and all. But these text and all, anyway, this neural network or your machine learning algorithm, say they need to perform statistics. So statistics means it's a max, part of max, and it should be numbers. So what if my data is in the format of image, or what if my data is in the format of NLP? NLP is natural language processing. Okay, so if your data is in the format of text, what you should do is, you have to find a way so that you convert your text into numbers. That will be done in the pre-processing and give it to your neural network or your algorithm. Like that, if you have image, see here, image is nothing but, if consider this as an image, In each corner, like each pixel value is going to be a 3 numbers. Okay, it is a 3 channel number, R, G and B color. So if you have that number, it will be how many pixels you have, you will be getting a matrix of your image. So with that you can perform the same processing. That's how it's done. So you have the data, you have to turn it into numbers in some way, and then you can proceed with that. And NLP is a machine learning technology that gives computers the ability to interpret, manipulate and comprehend human language. So this is a place where you will transform your text into numbers so that you can give it to your machine learning or deep learning algorithms. And is it clear about this till now? Because I'll be just jumping into the types of machine learning and what exactly happens in machine learning. And we need to see all the steps individually. I'll come back to this feature with this target later on. Before that, we'll jump into deep machine learning now, in-depth machine learning. Talking with that, we'll see the types of it. We have something known as supervised learning. Okay, so in the concept of supervised learning, you have a data which is labeled. So the label could be something like this. For example, this is my labeled data. Okay, and this is my labels. We know that this is a circle, and this is a square, and this shape is triangle. So I have their labels and I have my data. So I'll give it to my algorithm. So it learns that this is circle, this is square and this is triangle. So when I give a new image or a new shape, it predicts that as a circle because we have a label. So it just want to map either this or that or that. Okay, and in supervised learning too, you have like 2 types. So this label you have, right, it could be either a classification one. If classification means you have the data which is either something like this. What if you predict the temperature is going to be cold or hot tomorrow? Either this or that will be something like a classification problem, or something like a circle or a square or a triangle. You don't have any other choice, you want to choose between any of these. That is called as classification. Or you also have a data which is regression. It's not like either this or that, it's a range of value. From that, your particular value will be taken based on the statistics. And for example, there is difference, right? What is the temperature going to be tomorrow? It's a particular value. And whether it's going to be a cold or hot tomorrow, it is like a classified categories, right? So this is supervised learning. And talking about unsupervised learning, we have a data which is unlabeled. So you have your data with no labels. And the task of these unsupervised learning algorithms is to find similarities and group them separately. For example, we could see that these guys are separate, these guys are separate, these guys are different, and these guys are different. So like that, categorize and differentiate them. That's what this unsupervised learning is. Okay. And finally, we have something known as reinforcement learning. This is furthermore advanced, where you have an agent and it will be performing the action you mentioned in particular environment. So based on the action it performs, if the action is good, it will get a reward value which will be high if it performs well. If it performs bad, you will be getting a reward value which is very low. So that what happens is this agent over the time, the idea behind this agent want to increase its reward. So over the time it will perform all the wrong actions, and eventually over the time it will try to find which is the highest reward, so that it will learn and then improve it on its own. So that is reinforcement learning. It's used in games and all. And these are the steps which is involved in machine learning. We'll be discussing them one by one. First you need to get your data, right? So you can get your data in data collection part, and then we need to analyze it and pre-process it. We need to do train test split. Okay, we need to perform feature selection, then model selection, training, then predicting, and then evaluating and improving it. So starting with data collection, like for example, in a real-time scenario, if you are going to perform a data science case study, if some companies is asking you to perform for their business, they will be having their data, they will be giving it to you. What if you want to do on your own? You can either collect from, like if you are going to collect the heart disease data set, you want to collect it from a hospital with the consent of the patient, you can collect it. Like for example, if you are a student who want to learn data science, then you can use some of the open source data collection parts like Kaggle, UCI machine learning repository and Google dataset search. Okay, so these are some of the places where you can search dataset and get, for example, I have something known as Kaggle. Okay, so this Kaggle is a place, it's a community where you can download datasets. Okay, it could be any datasets. The accidents of in the US from 2016 to 23. You can search datasets too. For example, if I want, I can search. Let us go with weather. So I can get weather data like this. Open source dataset can be found here. So this dataset mostly will be in the CSV format, a normal format. You could also use Google dataset search to get data. For example, I have some sample dataset which I want to show you guys. So for example, this is actually a diabetes dataset. It's a CSV file. Anyone knows what is a CSV file? Anyone have any idea what's a CSV file? Any idea what is a CSV file? So CSV file is called as comma separated value file. So if you just get that file and open it with, yes, correct, comma separated value. If you just open it with a notepad, you could see that all the columns will be separated with a comma. So it's a delimited format where this is what the raw data is, and if you open it with this Excel tool and all, you will be getting some nice tables like this. And what this particular data set is, you know the column names. We have pregnancy, glucose level, blood pressure, skin thickness, insulin level, BMI, diabetes, pedigree function, age, and finally we have outcome. So this data set I have collected from Kaggle, and it's a labeled data. We have an outcome column, and if the outcome is mentioned as 1, which means that particular patient is having diabetes. If it's 0, the patient don't have diabetes. And the reason behind 1s and 0s is, finally when you give it to your algorithm, it should be completely in numerical format. You can have yes or no here, but you want to turn it into 1 and 0 in some way. If you have 3 outcomes, then it's like 0, 1, 2 and all. Okay, so you could see right here, each row I'm having here, right, it's from one patient. Okay, this is from particular patient. They had one pregnancy and their glucose level is 85, and the blood pressure, then skin thickness, then BMI, and their respective medical details. Finally the outcome is either they have or don't have. Like that I have collecting data for, this is a very small data set with just 770 rows. Okay, 770 patients only. Real world data set will be lakhs of rows. Okay, and this is how a data set will look like. I wish to show you guys about for example, we'll see, I have a car data set where the target here is your selling price. You will be predicting this. This is not any category, you could see, right? It's a regression problem, like the temperature you are predicting, right? Same way you will be predicting based on the car, what year they have bought, how much it has been driven, and the details with that you will be predicting whether whether it will be sellable or not, what could be the price. And yeah, like that we have a lot of data. And from this particular data, I just want to tell you guys what is features and what is target in the meaning of data sciences. Features means your columns which you have, right? It could be your the data set we have seen, right? Diabetes, in that the pregnancy level, the age, the glucose level, the blood pressure and all, those are called as features. And finally you are going to predict something, right? The label is called as target. Okay, that's the difference between features and respective target. And we will be doing a correlation. Do you guys know what's a correlation? It's the relationship between one and the other. So we can perform correlation also to find how this particular feature is affecting the target, how this is affecting the target, who is very important. Okay, for example, if you have a column which is called a serial number, will that serial number be anything related to the target, or will that serial number will help you to find anything like whether the patient will have diabetes or not? Right? Yes, correct. You could define that to dependent and independent values. Features are independent and target is dependent. Right? The serial number and all, they don't have such meaning. They won't be related with the target, so you have to neglect that. Those are some of the process which we will discuss now. So we know now what could be the data collection. So when you have your data, you can perform data analysis with Python tools like Matplotlib, Seaborn, okay, and you can also do analysis with Power BI, Tableau, and business intelligence tools. And after doing that, you can go for some pre-processing like feature scaling, encoding, imputing null values, and outlier detection and handling. I'll tell you guys what this is. What is this feature scaling? You guys know what is a feature? A feature means my independent values or my columns. So feature scaling is a method to normalize the range of features of data. So this can be done with methods like normalization or standardization, and it helps to avoid bias in machine learning model. The reason behind this, understand why we need to perform scaling is, if I have three columns, first one is age column, next is weight, next is length, and I could see that this age is actually a 1-digit value, and this weight is actually 2-digit value, and this length is mostly from 2 to 3-digit values, right? So when you pass it to your algorithm, your model or algorithm in machine learning can put more bias or weight towards the highest digits because of its capacity and size. It may consider length as important and provide more bias here, which we shouldn't be having. Okay, we shouldn't have that such things. So what we'll be doing is we need to perform scaling. So you need to find a way that if you scale it all these things into a single scale, okay, then the problem is solved, right? So for doing that, we can either perform normalization. So in normalization, this is the formula. So your new value will be your old value minus minimum value of that particular column divided by maximum value minus minimum value of that particular column. And if you perform this, your values will be between 0 to 1. How it will be between 0 to 1 is, for example, let us consider the smallest value, which is going to be 2, right? And the maximum value is 12. So if I want to find what's the value here, the new value for 2 is, it's 2 minus the minimum value, which will be 2 minus 2 will be 0. So now my minimum value have become 0. And if I go with my maximum value 12, if I find that it's 12 minus 2, which will be 10. And below the maximum value is 12, minimum value is 2, so it will be 10. 10 divided by 10 will be 1. So now if you perform this for all the columns, all your minimum values will be 0 and maximum values will be 1, and remaining values in between will be between the range of 0 to 1. So you can have it in a scale of decimal values, which is between 0 to 1. It's a way of scaling, and you can perform this with the help of a library in Python which is called as sklearn.preprocessing. You can import min-max scaler and you can fit and transform it, and you can also perform standardization. This is also a part of preprocessing. So you can use this particular formula, which is x, that old value, minus mean value of that column divided by standard deviation of that column, and this will help you to convert your values. New values will be, that particular column will have a mean value of 0 and standard deviation of 1. And if you have a lot of outliers in your data, you can perform this robust scaler, and this is what called as an outlier, right? Remaining data points are here. One guy is not at all related with the other and it's separate. It can be called as outlier, and if you have it, you can perform this robust scaler from pre-processing of sklearn library, and you can fit and transform this in your data. So this is like which is better, the use case of scaling. It could be like how, if you want to go with normalization or standardization. Okay, and robust scaler when you have outliers, when your data is Gaussian distribution. Do you guys know what's a Gaussian distribution? Bell-shaped curve. Heard about it? And talking about encoding, encoding is very easy, and the reason behind encoding is machine learning models can work only with numerical values, and for this reason it is necessary to transform the categorical values of the relevant features into numerical one. Like for example, you can either perform this normal encoding, nominal or ordinal encoding. So in nominal encoding you won't be mentioning any hierarchy or order, so you can perform a binary encoding like this. If you have three classes like red, blue and green, for example you can create a column for red. If it is red here, it will be 1 here and remaining both will be 0. If it's blue here, then in the blue column we will be having 1 and remaining things will be 0. So instead of this text we are just representing it in the format of numbers. You also have something known as ordinal encoding, and this nominal can be done with one hot encoder of sklearn preprocessing. This ordinal encoding can be done with the help of label encoder from sklearn.preprocessing, and you can transform this, and this is just going to split. Like the category A is now given as 0, B is given as 1 and C is given as 2. So like we have seen in the diabetes data set, right? Yes or no, 1 or 0. Like that we can perform here also. And for your testing purpose and all, what we should do is we will be splitting our data into parts. Okay, so when you have your data, your entire data, for example, if I have 1000 rows, I can split 0.2 here is the size, which could be like 0.2 means 20%. So from my 1000 rows, I could split 20%, which means 200 rows for testing purpose. I'll keep it separately, and this 800 I'll be training it. Once the training is done, with the help of that 200 I can test and evaluate it, and this evaluation will help me to understand how my model is performing, or how can I improve it and how can I compare it. It will be helpful, and it can be done from sklearn.model selection, and feature selection is also an important part, because see here in the data set I may have like multiple columns. Okay, for example, this is a data set. Okay, we have a lot of things here, and we have some part of text also which comes under NLP. So some details may not be important. Okay, some details like unnecessary details can be available, which is not important, means we need to remove that. So it's called as feature, and they are selecting, right? So it's feature selection. So it's desirable to reduce. So talking about random state, yeah, I have skipped that. About random state, it's actually a number. If you don't keep the random state, what happens is every time you run this train test split, the number of rows it's taking, right, the 200, it will be randomly picking, and every time you rerun it, it will randomly pick different versions of it. Okay, different. And if you go with a particular random state number, usually it is given as 0 or 42 or any number which you like. So what happens is in that particular random state it will pick. So if you rerun it, you will get the same 200 rows which you get. Why they are performing this random state is, like when you are initially building your algorithm, okay, every time if you rerun and get different data, it may be like it's not that much good for you to develop or build an algorithm. So to want repeatability, what they'll used to do is they'll set a random state, and if you check the documentation, you can find that controls the shuffling, so that particular process reproducible output can be obtained with random state if you give a constant value. And the feature selection is to pick important guys who is having like most impact on the target. For example, if glucose level and blood pressure is having the highest importance on deciding the diabetes, I can leave other things like age and other features. For example, I'm telling. And for feature selection methods, it's a lot of statistical methods. You have options like dropping constant features, correlation method, mutual information, chi-square test, and ANOVA F-value test. So these are some of the like you can obtain from sklearn library. It's a library for machine learning, and it's a lot of statistical tools to find how your features are related with your target. Once you've done all these things, it's time for you to choose the machine learning algorithm. He is going to perform the thing, right? So to select algorithm, we will be considering factors like nature of the problem, nature of the algorithm, and performance comparison finally. So for example, we know that we have three types like supervised learning, unsupervised learning, and reinforcement learning, and we have sub parts also. For classification, we have separate algorithms. For regression, we have separate algorithms. For clustering, we have separate algorithms. Like that, we have different algorithms. So that's what the nature of the problem is. So based on the problem, you have to perform it. And also nature of algorithm, you need to know about it. Like how this particular algorithm, like support vector machine, how it works. If I only know about that, then only I can decide whether I can apply to this particular data or not. Finally, you have a bunch of classification algorithms. For a classification problem, you can apply any of these and then test which is good, and then you can proceed with that. So these are some of the common steps which we use in data science and machine learning workflow. And if it's okay, we could see this demo of this particular project, which is telecom customer churn prediction. Can we see this, guys? Here I'll tell you how data analytics is really important. Yes. So talking about this telecom customer churn prediction, it's a common case study. Churn means nothing but leaving the company. So this is a business case study where we have a telecom company and they have a data of in the past few data how many people have left their company. So churn prediction is a common use case in machine learning domain. And if you are not familiar with the term what's churn means leaving the company, and it is very critical for a business to have an idea about why and when the customers are likely to churn or likely to leave their company, so that they can try to improve their their process so that most of the customers not churn or not leave their company, right? So we'll do some hands-on. I have that particular project with me. Let me just take that. Okay, so we'll start with, I hope I have loaded my data set. This is Google Colab where you can write your Python codes for data science and machine learning and work on it. And I'm importing some required libraries. Okay, and I'm loading the data with the help of pandas. It's a library to work with the data and loading the data and handling it. And data.head will give you the first 5 rows. And I have columns like customer ID, their gender, senior citizen or not, partners, whether they are partner or not, dependents, what's the tenure month, phone service, multiple lines, whether they have internet service, and I have a bunch of details here. Finally, I have a churn, which is yes or no. Can you guys tell me which type of machine learning problem is this? This is it. You are going to perform data science, but to do that you need machine learning as a tool to predict, right? So considering this as a machine learning problem, what type it is? It belongs to supervised learning classification problem, right? And you could see that I have given a description where I have collected the data set. 1 means senior citizen, 0 means not, and yes or no and other details about the data. Okay, and I'll scroll below with info to give you the data type of each. Okay, so I'm going to select some target variables. Okay, so this target variable is churn, right? Yes or no? I have my data set, which is something like the shape of it is nearly a customer detail of 7,000 people, where 5,000 people have stayed in that company and 2,000 people have left the company. Okay, so this is a data analysis graph. From this, what you can see, the number of count, nearly 2,000 have left and nearly 5,000 have stayed the company, right? and you could see, right, instead of viewing this will be furthermore better. And yeah, so we'll go into that, and we are going to select some categorical features, which are categories, yes or no, something like that, male, female, or categories. I am selecting that particular columns, and I'm just going to use a for loop and perform this count plot, so I can get a count of how much people we have. Okay, so I'll just zoom out a bit, and the gender count you could see in my data set at the 7000, it's nearly equal, right? Male are high, but it's very little differences there in my data, male and female count. And if I scroll below, the number of senior citizens, one means they are senior citizen, and we could find that the senior citizen count is nearly 1000, and remaining 6000 are like they are not a senior citizen. Scrolling below, how much people have partner, yes and no, they are little bit equal, no is high. And then count of dependents, yes is less, no is high. Phone service, if they avail, most people avail phone service, the yes is high. Okay, whether they have got multiple lines, okay, so we have no S, and if they don't have phone service, there is no lines, right? And the internet service, whether they opt for DSL or fiber optic, or they haven't even opted for internet service. And then the online security, most of the people haven't bought it, only a few have done. And the online backup, most people haven't. Okay, protection, most people have haven't done. Similarly, tech support, most people haven't obtained that. And streaming TV, you could see that nearly people have got yes and no are nearly equal. And the streaming movies are also nearly equal. And the contract tenure, right, month to month is high. 1 year contract people are less, 2 year people are little bit high. Okay, this is the count of them in this data set. And the paperless billing method, payment method, and all, electronic check is used a lot of places. And we also have another one, I'll just show this detail. Of the senior citizen percentage and all, how much they have. And this what this telling us is, we are adding another feature in the count. Okay, so the percentage of customer senior citizen, okay, yes or no, how many people have churned, we could see the difference, and we could observe that senior citizens have high rate of churn, nearly 42% are non-senior citizens. And talking about the partners and dependents, okay, so we get that customer, they don't have partners, and dependents are most likely they are churning. Okay, yes means the churned level is less, so that's what the idea behind it. And the phone services, this is what their count, and customers with multiple phone services have high rate of churn. Internet services, like that we can perform a lot of data analysis and understand the data better. So these are just data analysis part. Okay, so we have a lot more of data analysis. From that we could understand what is the important factor and all. You could also get a correlation of how one is related with the other. And we could see that one important thing is gender is not a deciding factor here, because both the count of male and female are nearly equal, and both the churn count of male and female are also nearly equal, which means that more people, like the gender here is not an important factor or deciding factor. You can perform with Python itself with these tools. Data analytics, if you want to build the dashboards and all, you can go with Power BI. They reduce the part of coding. You can directly drag and drop and attach some features and get nice inputs. Or here, if you want to perform that, you want to perform a lot of codings, right? And yeah, so this is monthly plots of this, and this is a scatter plot of monthly charges and tenure, and how many people have churned in that. And this is scatter plot of tenure, total charges, and the hue I have given based on the color is churn. And what can you observe from here? We could see that the total charges is high, means their tenure is also high, and the people, a lot of people are churned. We could see that a lot here. Once you've done that, what we'll do is we'll do pre-processing, where this is what the part we have seen in the slides. First you have to select your feature separately and target separately, target your churn separately, and once you have it, you can go and perform. For example, this is min-max scaler to perform normalization, so I am just turning them into a single scale, and I am just turning it in X, and you could see that I have to perform a scaling, and this customer ID and all is unnecessary thing which I have to draw. Okay, so I'll select the important features, and I'm going to perform label encoder to perform ordinal encoding, and I am also getting which is mapped as which. So in gender, if 0 it means female and 1 it is given as male. In senior citizen it is their partner, no means I have given as 0. So like that I can get a directory of what it has been done, so that I can't mismatch, right? So we are also performing it for our target, and we are performing the train test split to split with the test size and random state, and this is the shape of it, and this is for feature selection, right? The statistical tools I have told. So we will be selecting a particular details. Okay, it seems like run before, like when you run it in between and all, something may be mismatched and you may get some error. We'll go in a flow from the start. Yeah, now it has been fitted and let us get the support of it, and wherever it is true, if you count it, here I have asked for 6 important features which has effects on the target. So it is giving me 6 true based on the position. If I just use the index and get it, these are the important features it has been given for prediction. So I am just selecting that and going into the modeling part, where there is an algorithm which is called as decision tree, which is a classification problem. So it's a classifier. So I am just training it here. This fit is a place where you train it, and this is where you predict for your testing. Okay, and then you can compare it with the answer given by your model and the original answer of test, and you can get the accuracy score. And I am nearly getting about 73% accuracy in the test I have conducted. So it can be a range of nearly 100. So if it's near to 100, which means it's performing really well. If it's around 70, you need to improve it. If it's beyond that, you need to, like if it's below that, you need to improve it furthermore. And this is a plot of how much it is predicted correctly. 0, which means churn, not churn, correctly predicted as not churn in 1200 places, and churn correctly predicted as churn in 282 places. So like that, you also have random forest classifier. I perform the same thing and get the accuracy. This is really performing well compared with the previous one. Also, there are some more concepts like imbalance and all. Here we have seen that the churn, okay, it's 2000 and 5000. It's their like distribution. We can't go with that. We need to do something like we need to sample and then go with that, which can improve the accuracy. And also we have other algorithms like support vector machine and all. From this, which is best, you can pick that. For example, this is giving me best, right? XGBoost, which is model 4. So I could pick that and create a predictive system. For example, this is a predictive system of tenure. If I could enter the tenure, okay, and the online security, tech support, contract, paperless billing. So these are the things I have trained, and if I give the answers for it, what it will do is it can be stored into a list, and now you can ask your model to give answers. So it is telling me that for this particular detail the answer is no. So this is what the idea behind data science is. So if you have a bunch of new customer data, your past data of 1,000 people, you can get predictions for them as 0 or 1. So if it's 0 or if it's 1, so you can decide if it's 1, so you can improve your process so that the customer stays and not leaves the company. And that's a simple idea behind data sciences. Any doubts? Any doubts which you want to discuss? Or is it clear? So that's it. Thank you. Thanks for watching. Thanks for attending this webinar. Thank you. Yeah, people used to use other tools like R programming and all. Uh, if you know Python, it will be really good. It's easy and it will give you a lot of options and a lot of freedom for you to use different places. I'll suggest you to go with Python. Thank you.